with a super tiny eye implant. Scientists in China just gave blind mice their vision back and gave primates with healthy vision infrared vision. Yes, that's the vision Predator had. Sounds fake, right? Well, let's talk about it. What's up, everyone? Lance Johnson here, and I'm going to cover a really interesting article. And if you're someone like me who has a retinal eye condition, then this video will be super interesting to you. All right, so this article is from neurosciencenews.com, and the title is Nanowire Retinal Implant Restores Vision and Sees Infrared. Now, I'm going to be honest with you. This article is written in like a very scientific manner. So a lot of it, when I go over it this first round, it's probably going to go over most people's heads. It goes over my head. Like I had to ask ChatGPT, like, can you explain this to me as if I were a kid to understand it? But don't worry, I'm going to explain everything in a very simple way. But I do have to cover the article. So let's just go ahead and get into it. So it says, researchers have developed a retinal prosthesis made of tellurium nanowires that restores partial vision in blind mice and enables near-infrared vision in primates. The implant, woven into a lattice of light-sensitive nanowires, converts both visible and near-infrared light into electrical signals for the brain. I told you it was written scientifically, but don't worry, I'm not going to cover the whole entire article. I just want to kick it off by going over the intro. In blind mice, it restored visual reflexes and behavioral vision, while in macaques, is that how you say that? Excuse me if I said something sounding a little risque there, but it enhanced detection of wavelengths beyond natural sight. This breakthrough marks a major step toward restoring vision in the blind and augmenting human vision beyond current biological limits. Sounds good. That sounds real good. And here are the key facts. And I'm going to go over these in like a very simple, matter-of-fact way. But the key facts are vision restored in mice. The nanowire prosthesis restored pupil reflexes and visual cortex activity in blind mice. So basically, these little wires that they implanted into the eye of blind mice gave those blind mice usable vision, mostly in the sense of like lights and shadows. A quick example would be like if you had a mouse and you shined a flashlight into its eyes. If it was blind, it wouldn't know that you were doing that, right? It wouldn't register. You know, doesn't matter if you shine it right into the mouse's eye. But with this nanowire technology, now mice are able to see lights and shadows. So now they would know the difference between, you know, a light being shined in their eye versus not shined in their eye. So basically, it restored some vision. It sent a signal from the mouse's eye to its brain, which is what happens with our vision. I don't know if you knew this, but like our eyes are basically just hardwired straight to our brain. You know, so we don't really see with our eyes, we see with our brains. So moving on, the infrared vision part in the monkeys, you know, the macaques, monkeys. I'm just going to call them primates or monkeys from now on. Sorry. But sighted primates with the implant gained sensitivity to near-infrared light. So what that means is basically, you know how they gave it to the blind mice and it restored some of their vision. It helped blind mice see something. So this part of the experiment is like, all right, what would happen if we gave this implant to monkeys with healthy vision already? So they gave this implant to monkeys with healthy vision, and it gave those monkeys infrared vision. Now, infrared vision is special because infrared vision picks up on, you know, light particles that our normal eyes cannot see. So the fact that this gave monkeys extra vision, it basically gave these monkeys like super vision. Not only could they see what they normally could, but it also let them see other elements of light that they were not previously able to see. And then to wrap up the key fact here, it says safe and biocompatible. The implant showed no adverse effects in blind monkeys, supporting long-term clinical promise. Now, the rest of the article, I mean, like I said, it's a pretty intense article with how they wrote it. But I'll cover key points from this article because a lot of it goes over my head. I just read it and it sounds like I'm reading from a technical textbook. But it says the new technology's feasibility and strong safety profile marks a milestone in the development of artificial vision, which could prove invaluable to patients worldwide who are living with blindness or retinal diseases. And why that matters is because, you know, for example, I have an eye condition called retinitis pigmentosa. And I have retinal cells that are dying and they're not regenerating, which means I have less signals coming from my eyes to my brain. So how that affects me with retinitis pigmentosa is basically with RP, my photoreceptors in my eye, so the receptors that send signals from my eyes to my brain, slowly stop working. This implant will help continue to send signals from my eyes to my brain, which will give me vision. So hypothetically, it could help preserve or even restore, vision in people like me with retinitis pigmentosa. And then it goes, currently there are many approaches to restoring vision in the blind, but almost all of these treatments face obstacles such as electrical interference or a lack of long-term efficacy. And then it goes, at the same time, researchers are also trying to augment the human eye's capabilities to detect other wavelengths of light, including near infrared, such as a technology could be a boom. They wrote boon, but I'm assuming they meant boom, to vision restoration efforts, as detecting near infrared light would provide better color contrast and be helpful in dark conditions. Let's see if there's anything else from this article that quickly stands out so I can share it. It said blind mice with the implants also performed better on pattern recognition tests and could find LED lights during a behavioral test and eventually almost matched the performance of normal mice. That's awesome. And it says, and this is probably important, but it says the long-term success of these technologies depends on developing cost-effective solutions and ensuring their availability to a broader range of patients. And the reason why all of this matters and why I'm sharing this with you is because this, like many other things in the works currently, could be a possible tool used to restore vision for people like me with RP, or you with your retinal eye condition, or people who are born in the future with eye conditions. There's so much going on, and this is another piece of that puzzle. And apparently it's super small and it's super safe and it doesn't hurt. It's not painful on the eyes, according to this article. And it could help humans, even with good vision, see invisible light, also known as infrared light or predator vision. And I just think the whole thing is super cool. I'm sure the military might want to get in on this. I don't know if they want to permanently change people's visions by putting microchips in them. But, there's some really groundbreaking stuff happening out there. And a lot of it sounds science fiction, but it's all real. And in the most basic way, it's kind of like a superhero upgrade to our vision. And it's something that I think is cool, something you should check out and know about. So that's why I wanted to share it with you. So let me know if you want me to cover more articles like this. Let me know your thoughts on this study. Let me know if you think it's something you're excited about. Are there other studies I should cover? If you have any other ideas for me. And if you like this video and found value in this video, please like this video. And if you haven't yet, please subscribe to my YouTube channel. It helps a lot. And with that said, that's all for this video. Cheers.